Alright, hey, welcome to Retro Computing. I'm doing a different kind of talk in this video. So I want to talk about something I'm calling the PigBus. This is a virtual device that hangs off the UNIBUS on a simulated PDP-11, but it's designed to allow you to create and install custom devices after you've already compiled the PigBus into SimH, so that you don't have to rebuild the entire simulation system in order to add a new device. So what have I been up to? If you've been watching the lectures, you know I've been playing around with PDP-11 emulation through SimH and PyDP. I'm getting a front panel soon from obsolescence.dev. That's their picture, and hopefully that's a present coming up in the next few days. And so what is SimH and the PyDP-11? It's a PDP emulator, although it's a lot more. SimH can emulate lots of different kinds of hardware systems, Vaxxon, Nova, IBM's, all kinds of different hardware. I'm just using it for the PDP-11, and PyDP-11 is a version of SimH that works with a blink and bone panel, so you can have actual switches and lights to interact with the emulator. It's a lot of fun to play with, and so I've been making videos as I've been messing around with this, and the videos have been things like, you know, PDP-11 architecture, addressing modes, instruction set, basic setup like that, using PyDP to run some code from the front panel, coding things in macro, looking at tool chains for going from assembly language to machine language to object code to loading it into the simulator. I've also looked at some interactions with devices, consoles, and so on, and did a video on interrupts. So that's all fun, but today I'm talking about moving at a lower level than that, going inside the SimH software itself, because the system is really easy to hack, and it's super fun to play with. The code is so well written, it's so clean, it's very consistent, the documentation inside is superb, and so it's a really easy system to understand and work with, even just kind of groping around without you know, documentation telling you what different things do. It's pretty easy to figure out. It's a total joy to work with. If you're interested in this, I think the path a lot of people are following is basically on the obsolescence website. There's a link labeled hacks or hacking, and it takes you to a page where Oscar adds an I2C device, a barometric pressure and temperature sensor, into their Raspberry Pi and sets it up on the UNIBUS in place of the paper tape reader. So they basically take the paper tape device code from SimH and repurpose it. So that's fun to do. It's great to mess around with. The challenge I ran into when I first started trying to do this and rebuild the simulator from source, it was not working. I was having problems where a lot of the RPC code had changed locations, header files were missing, and so on. That turned out to be mostly pilot error, because I had a very old version of the source code. When I got the newest version, it compiled beautifully. But it makes me generally nervous, because more often than not when I try to build executables from source, this is what happens to me. You configure it, you say make, it runs for a while, and then you get some error about, you know, wrong number of parameters to a function call, or missing files, or conflicts, or things like that. And you either dig in and become an expert on the system, or you start searching online, hope somebody else is running the same thing, or you give up. So, you know, in the back of my head I'm wondering, like, okay, so this is all great, but a few years from now, if I want to add a new device to my PyDP-11 and I can't recompile the source code, what am I going to do? So I came up with this system I call the PigBus. Basically, it's a single UNIBUS device. You compile it into SimH one time, and then once that's installed, you can go ahead and you can make custom devices and attach them to the PigBus without recompiling SimH. In fact, you can actually hot swap on a running simulation system. So all the communication is done through shared memory and one pipe. And the protocol for creating a device, I designed it to be very general purpose. Time will tell if I succeeded in that or not, or to what degree I succeeded. But it's designed to let you write different devices, either virtual devices or physical devices that are actually hooked up to the underlying hardware. So hopefully general purpose system. So why did I do this? Rapid prototyping, right? So I love when I'm working on a project, not having to wait for the tools to do the things that I ask them to do. I think this comes out of, having come up in a time when compilation meant go get a cup of coffee. So very rapid prototyping, right? You make the code for a device driver, compile it, reset the device in your simulation, and you can start testing it. So that's good. Never need to rebuild SimH from source, so that worry goes away. No matter how many devices I put on the PigBus, the whole thing only takes one block of address space in the UNIBUS, 4 words, 8 bytes. I only use 6 of those 8 bytes, 2 of them are reserved. So it's not a constant hunt for UNIBUS addresses or vectors that you can repurpose without collisions. So that's kind of nice. But the real reason I did all this is just fun. Right, it's always fun to set up protocols for communication and control of devices and interfacing and so on. So it's been a cool project, and as I developed it and as a proof of concept, I've made a few devices so far. One is an alarm clock or a timing system. Another is a file I/O system that lets you read, write, and delete files on your underlying hard drive. I made a kind of toy server socket. It's not a very sophisticated server. It only takes one connection at a time, but as a proof of concept. I also made a goofy device that implements a bash shell, so you can send out commands one character at a time to this device, and after you send a new line, bash shell will execute it, and any output produced comes back to you, and you can pull it in from the device one character at a time. And then on the PDP-11, the Raspberry Pi based system, I implemented a PCF 8575 GPIO expander that you can get to through the UNIBUS. Other people have done this as well, of course, but it's another device through the PigBus. So I don't claim that this is useful or interesting to anybody except myself, but I've been having a lot of fun with it. And I'm thinking that going forward it will be a way that I can add devices onto the system down the road. So if you're still with me, what are we going to do in this video? So general PigBus setup, we've talked about most of that already, but I'll go through the simulation and show you some of the commands related to the Pig. And then I'll demo a sample device, which will be the alarm clock, and show you 2 alarm clocks running at different periods. And then we'll look at the macro code for that sample program and see how we interact with devices through mostly just a pair of registers, a command status register and a data register. And then we'll go ahead and wire up a new device on our own to make just a simple adding machine program. And then take a quick look at some other devices.